All right, so for this first question, I don't know if you are aware of this, but for something to be a perfect square, each prime factor, so when you break it down into its prime factors, each prime factor has to occur an even number of times. So if this is the prime factorization, basically we're missing another 5, and we need another 101. So that means that 2020 times 5, times 5 times 101, that's what n would need to be, which is going to be 505. So 2020 in itself is not a perfect square. To make it a perfect square, you need to have at least, so you need to have each prime factor needs to occur an even number of times. You need at minimum 1 more 5 and 1 more 101. So for this one here, if I were to draw out the net of a cube, I would end up with something like this. What you're going to notice is at any one time, so let's say, for example, I'm on this face, I'm going to be adjacent to 4 other faces. So if I had a color green, for example, I couldn't put a green here, 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 or here. The only other place I could put a green would be here, which would end up actually being opposite. So if this were the bottom, this one ends up being the top. Likewise, if I put a blue here, this one here would be adjacent, this would be adjacent, this would be adjacent, this would be adjacent. So the only place I can put another blue one would be here. And then finally, let's say I had red, and I need to be here. So I can only put them on, excuse me, opposite faces. So I need at minimum 3 different colors so that no 2 faces that would have a common edge, so an edge would be where the faces meet, that would have the same color. So this one here, there's a couple of different ways you could approach it. One way would be to literally write down all the possibilities and then see how many are prime and how many there are in total and get the probability. Another way would be to realize that if there's 5 numbers in this set and there's 5 numbers in this set, the total number of numbers you could make would be 25. So that's going to form the bottom of your probability or your fraction. Now what you have to do is figure out how many prime numbers can you possibly make. So let's go through all of the different prime numbers. So 2 is the smallest prime number, but that one won't work. So let's look at creating 3. So there is only one way to make 3, a 2 and a 1. So there is one way to make 3. Then let's look at the next prime number, which is 5. So we can make 5 using a 3 and a 2, or a 1 and a 4. So there are 2 ways of making 5. Then let's look at 7. How many ways could we make 7? So we could do a 5 and a 2, a 3 and a 4. So we keep going through, and we end up seeing that there are actually 3 ways to make 7. If we keep going, we would have the next prime number will be 11. And again, go through how many different ways would there be to make 11. You're going to end up with 5 different ways to make 11. The next prime number would be 13. There are going to be 4 different ways to make 13. And the next prime number would be 17. You're going to get 2 different ways to make 17. And then the last one would be 19. And there is 1 way to make 19. If you add all these up, 1 plus 2 plus 3 plus 5 plus 4 plus 2 plus 1, you will end up with 18. And remember, there were 25 possible numbers, so your probability will be 18 over 25. So for this one, the best strategy to use, I think, would be to think about breaking it up into how many 1 by 1 squares might there be, how many 2 by 2 squares might there be, how many 3 by 3 squares might there be, and how many 4 by 4 squares. So what I mean by that, well, the 1 by 1 are quite easy. You just count up, and there would be 22 in total because there were 24, and then you took away. So 2 by 2, what I mean is like there is a 2 by 2, there is a 2 by 2, there's a 2 by 2, but then like there's another 2 by 2 there and there and there, and so they'll start to overlap. So it's just figuring out how many would there be in total. So there's going to be 13 2 by 2s, and then again, we erase that. You could go in and you could think about, okay, how many 3 by 3s? So like there's a 3 by 3, there's a 3 by 3. There'd be one in here, there'd be one like here, and so on. Okay, so you're going to get 6 3 by 3 squares in total. And then looking at how many 4 by 4s that you can create. And because it's cut off, if you shifted this, for example, like that, oops, it's going to be missing a hole. So that's not possible. Or if you tried to shift it this way, oops, it's missing, again, it's missing a hole. So there's actually only going to be one 4 by 4 that's possible. So the two that are the trickiest are actually these two right here. They take a little bit of thought, and it can be hard to kind of visualize that. If you add these all up, they're going to be 42 different squares that could be made. So for this problem here, I'm hoping some of the grade 8 students had success with this problem because we've been doing some work with percent. So basically, you took 30% off, you have a new price, and then what the store is going to do is it's going to mark that price up again to go back to the original. I'm really hoping that you realize that if you take 30% off, you're not going to then go up 30%. That will not get you back to the original, because again, the things that we've been talking about, 30% off a higher number is different than what 30% off that discounted lower number would be. So one of the ways to approach this that I would recommend is to just sort of say, okay, what price might this jacket be? And sort of make up a price and then see what happens and then see if you can figure out the percent that you went up. Because you're not allowed a calculator for this, pick a number that's going to be really easy to work with, like $100. So let's say the jacket was originally $100. When you take 30% off, that means because it's $100, you're going to save $30. And the new price is going to be, so the sale price is going to be $70. Now what we need to do is figure out what do we need to do, what percent do we need to add on to get back to 100. We know that we need to add $30 to get back to the original. So really what we have to be thinking about here then is what is 30 out of 70 as a percent, right? That's really what we're doing, because now we're saying $30 added on to the 70. What would that be as a percent? So this one would be, again, sort of a little bit tricky maybe to think through without a calculator, but it's doable. So it's like 3/7. So if you find an approximate number for 3 divided by 7, I mean, you really could think about this like long division if you wanted to, right? And think of it this way. So 7 will go into 34 times. You'd get 28, you'd have a 2, right? Bring that down. That's like going to be 14. Whoops, that will be there. Oh, sorry. I guess it would be 2. I'm a little bit tired right now doing it. Now it's not going to erase that. Okay, so we're going to end up with a 2 there. We'll get 14, have a 6. So that'll be an 8, and so on. So if we took this number and we times it by 100, we'd get 42.8. So to the nearest whole number, that means 43%. So we had to take off the 30% to make it $70. We need to add 30 more dollars, but then it was $30 out of not the original 100, so it's not going to be 30%. It was $30 out of the original 70, which will end up being 43%. So that's going to be the answer to that last one. If you have any questions about any of these, please see me. Please come and talk to me.